So one of the things that has been observed in data is that when we start thinking about how is our data distributed and what's our data look like and different numeric measures we can create to be descriptive statistics to give us insight into our data. And I'm being very methodical about how I'm saying all this because I'm wanting to be precise with my words. And it's a little bit complicated. But it's also at some levels when you like just really step back and kind of look at it, it's like, okay, that makes sense. This numeric measure, this descriptive statistic, it makes sense. Like all of this stuff that we've talked about, it all makes sense. They're great descriptive statistics, numeric measures, which give us insight into our data and our data set, including the z-score, which we just did. Like, yeah, that gives you insight into each data point. It tells you how many standard deviations that data point is away from the mean. But one of the things that has been discovered in statistics is that when we look at the distribution of data, we can see that data, a certain amount of data falls within a certain number of standard deviations of the mean. And so data, generally speaking, is going to have some sort of a, some sort of a grouping, some sort of a, there's going to be more data closer to the mean than farther away. And that's just the way data has worked. And so there's some rules that we're not going to look at like how these were arrived at or derived, but we will see how to use them. And so one of the rules, this theorem, is Chebyshev's theorem. And basically Chebyshev's theorem is if we take this z-score right here, and we use like one standard deviation or two standard deviations or three standard deviations, any value that's greater than 1 but not 1, right? If we do that, it'll tell us how much data, this little formula here, is within that many standard deviations of the mean, where z is the number of standard deviations we want to find. So 1 minus z squared. So let's play with that for a second. And to do that, I'm going to come over here. I'm going to create a new spreadsheet. I'm going to call this Chebyshev. Right, Chebyshev and z-scores. And I'll put a z-score here. And so here's my z-score. And I'm going to do like 1.1, and I'll do 1.2, and I'll do 1.5, and I'll do 1.9, and I'll do 2, and I'll do 2.5, and I'll do 3, and I'll do 3.5, and I'll do 4. And then Chebyshev's theorem tells us that we're going to have is equal to 1 minus, and then it's going to be 1 divided by, and it'll be divided by that squared, where this number here, right, is the z-score squared, so it'll be that times that. So Chebyshev's theorem is 1 minus, I'm just going to press enter on that and then show that formula again and then bring up that little sheet that I've put together here. But Chebyshev's theorem says 1 minus 1 over z squared. So here we have 1 minus 1 over, and our z is 1.1. A2 times A2 is how you'd square that. And so here we're going to calculate, and this is data within percent of data within this many standard deviations of the mean, right? Where z is the number of standard deviations on both sides of the mean. So if you just think of the mean of some data, like let's say our mean, as like in this example, is 10, right? Here the mean is, and let me go back to that, our mean is 10. If you think of that, like within 10, we're going to have, within 1.1 standard deviations, we're going to have 17.36% of our data is going to be within 1.1 standard deviations. And if we copy this down like this, you could start to see that, like, okay, within 2 standard deviations, we're going to have 75% of our data. Within 3 standard deviations, we'll have 88.89% of our data, at least, right? And within 4 standard deviations, we'll have 93.75% of our data. And so we look at our textbook presentation, or PowerPoint presentation that comes with the textbook, and we come down here and we look at Chebyshev's theorem. This is where it talks about it. But it says that 75% of the data must be within 2 standard deviations, 75% within 2 standard deviations, 89% within 3 standard deviations, 94%, well, when you actually calculate it out, it's 93.75 without rounding. But the 90, for standard deviations, you're going to have 93.75% of your data. So that's what Chebyshev's theorem talks about. And as we start to become conversant with standard deviations and understanding, like, okay, what is the standard deviation, right? Here's the standard deviation for this data set up here. This is how much the data varies, the standard for how much it deviates or varies. As we become conversant with standard deviation, we start to understand standard deviation. We'll use like z as the number of standard deviations from the mean to gain insight. It's a numeric measure that's a descriptive statistic to gain insight into our data, right? So we could say, okay, and this is just a theorem. It's kind of a rule. It doesn't really, for all data sets within 4 standard deviations, you're going to have 94% of your data. So that's all Chebyshev's theorem says, and it's starting to give us insight into data and data sets, and that's the explanation. That's the explanation of Chebyshev's theorem. It's like one of those things which is like you should know it, and occasionally we'll come back and reference it through the course, and we'll start to see how we start to think about our data, how much when we think about, okay, where's the mean, what are the standard deviations, how much data is here versus there, we could start to gain insights into our data that will allow us to make decisions and take action. So we could gain actionable insights into our data. And so Chebyshev's theorem starts to point us in that direction. All right, that's Chebyshev's theorem.